Some home upgrades change the way a space looks. This one changes the way it feels. At this San Clemente coastal home, an aging HVAC system is being replaced with a comfort solution designed for everyday living.
Here in Southern California, there's days where you want to run the heater in the morning and then the AC during the day. It's year-round needs for heating and air conditioning to stay comfortable. I'm Cody Novini. I've been in the HVAC industry about 15, 16 years, and now been consulting and helping other companies. Sat on the board for the ACCA. With older systems, they get less efficient. It's overheating, which causes it to draw more energy. The AC actually cools the home less. When you don't maintain your system, the corrosion ends up causing a refrigerant leak. This home is drastically oversized in heating capacity, and you'd think, oh, it's doing great, but it's not comfortable.
When Cody and I talked through it, he actually needed way less than what the old system was doing. So 2 3-ton Midea EVOX G cubes was perfect.
Heating and air conditioning is for comfort. It's a comfort system versus an efficiency tool. With the Midea system, what's awesome, especially for the installers, is that it's much smaller and more compact. It's really nice that the Midea actually comes apart in different sections. We're able to get each section up individually, even in tight spaces.
When the guys are lifting that into the attic, it's safer and it's faster. That air handler actually has auto voltage detection.
Whatever the house is providing, we're able to hook up and it automatically knows what voltage it's using. So it's really ease of use for our production crew. Screwless latch design. It's screwless self-sealing for the homeowner. They don't have to worry about hearing the drills constantly throughout the day. I think with a company like Midea, it's got such a large footprint in the whole world. They have a lot of research over all the different type of climates. There's a strong stability behind them. It's more ironclad that I can trust that the brand's gonna last a long time.
We gave you a lot more room on your walkway here. This is putting out probably 55 decibels, which is basically the sound of a quiet conversation.
And I love the look. It's so sleek. There's nothing else that looks like this. It's extremely quiet. It's not blasting out a ton of air all the time. With variable speeds and inverter systems, it just flows the warm air or the cool air to keep comfort right where you want it to be.
We've got outdoor unit, indoor unit, wall control, and they constantly communicate. It's going to do what it needs to do to keep it at the comfort level that you want. So that's a good thing.
It's great. I really like the dehumidification option. It's got all the features that I want in a thermostat. Good heating and air system, you don't even notice it. It just does everything automatically on its own. For me as a homeowner, I want a system I can trust that it's gonna last, it's gonna perform well, it's gonna keep the home nice and comfortable. Hi.
Hello, everyone. Thank you so much for joining us again on Did You Know, the ESCO HVAC show. Yes, Alexander, I know, I was just looking at it. That was an intro video. The YouTube didn't look like it was broadcasting it properly, so I'm going to be checking into that as we go through and see. It looks like it's starting to pop through now. But I appreciate everybody joining us, and let us know where you're chiming in from. It's always great to see how large our community grows week after week. So I'm here in Brownsburg, Indiana, just sitting in the studio, trying to get this thing cleaned up. We did an entire week of video shoots last week. So Todd and I are just absolutely like in recovery mode. And the poor studio looks like an install van. So those of you that know what an install van looks like after an install, that's what the rest of the studio looks like right now. So we're not even going to be sharing photos of that at the minute. So, I spend a lot of time talking about high performance heat pumps. And most of the time, we're relating those to, cold climate applications. That's good to know that it was a bit delayed. I thought that it was. Appreciate that, Maria. But when we talk about heat pumps in general, the word cold climate keeps getting utilized. And I would like for us to change that and kind of get away from that. It all came from that cold climate heat pump challenge from the Department of Energy a while back. And so a lot of places around the country have kind of struggled to adopt the technology because maybe they don't think that it applies in their area, especially if they're not cold. So today we've got some really, really enjoyable guests with us. David Rames has been on the show, been on the podcast quite a few times with us from Midea. David, thanks for joining us.
You're welcome.
And Cody, you want to go ahead and introduce yourself to our audience since you haven't been on the show before?
Sure. Yeah. Hey, everybody. I'm Cody Novini. I've been in the HVAC industry about 15 years or so. I've been a contractor, been a service tech, worked my way all the way up to business owner, sat on the board with ACA for the past 7 years, and now I'm on the board with IHACI here in California.
All right. So Southern California at that, which is really intriguing when we start talking about the applications for high performance heat pumps. So anyone that has questions today, let us know. We're going to be talking about the installation and the benefits of what our newer generation of inverter high performance systems are doing, particularly this EVOX GQ, which is just an insane performer. And we're going to be looking at converting from a gas and AC system into heat pump only, and in applications where we don't need any resistant heat at all, and looking at what it takes to do that. We're going to do some case study as well. So gentlemen, I really appreciate you hanging out with us today. So let's kind of set the stage for where we're at. I've talked about the EVOX before on the show. We've done some extended heating data comparisons, and it really has been quite the product. Guess I jumped ahead a little bit, didn't I? As we introduced Cody in there. David, go ahead and tell us a little bit more about yourself for the audience that may not have joined us on other previous episodes.
Yeah, would love to. So Clifton, thanks again for having us on. And we've done a few together. They've all been awesome. So my name is David Rames. I'm the Senior Specialist for Product Promotion and Development, a super long title, but the bottom line to this title is I get to help with a league of experts here at the American Research Center of Louisville, Kentucky. I get to help develop some of the coolest, highest performing products in the market. And then when we're done developing them and get them into the market, I get to go out and do really cool stuff like this and promote those products. And so I get to wear several hats and just have a lot of fun doing it, especially when you're putting out products like this. I mean, if you don't get jacked up and have energy and enthusiasm about these products, then you're dead.
I agree. I get a lot of slack, especially from installers, because I'm constantly talking about the technologies. When I was at AHR this year, I had a guy walk by. He's like, "Man, I love your show, but aren't you tired of talking about heat pumps yet?" I'm like, "No, not at all," because the technology is evolving and adapting and changing so rapidly. We have to talk about it. This particular product, when we were looking at solutions, we're going to talk about briefly about the two ranges of operation in this. It's high heat performance, it's high cold performance. If you haven't seen the video that David did for the Discovery Channel that was up in Alaska, wasn't that one, David?
Yes, sir.
All right. And so that one was using, this EVOX generation of heat pumps in ultra low temperatures, which absolutely we can consider that a cold climate, but the performance that they have is way beyond cold climate applications. So let's talk a little bit about the growth, because we've all seen a lot of growth in Midea over the last few years, and we've seen the presence of Midea in the high performance realm. Let's talk about Midea just for a minute.
Yeah, so Midea Group, who I refer to as the mothership, right? I always joke we're just a little mom and pop shop with close to $60 billion in revenue and almost 200,000 employees. Just moved up to number 231 on the Fortune Global 500, which is a big deal. A top company for women to work as well. And then, some of the brands you may recognize. I would say we joke internally that 3, 4, 5 years ago, no one knew who we were. And now a lot of folks in the industry know who we are just because of the products that we're putting out. And so some of the brands you see on the right there, whether that's Eureka Vacuums, Midea Group owns, Kuka Robots, Midea Group owns. But GMCC is an important partner for us, which is our sister company who does all of our compressors. And so when your sister company manufactures compressors, you just picked up a phone and call your sister and say, I needed to do this. And just like the Alaska project up in Willow, they made it happen. And so it's so good to have that under the Midea Group umbrella.
Yeah, I agree. And I've seen the growth myself and have been intrigued with the direction that it's went. All right, so what brought about the EVOX generation?
We knew, and Midea has been in the ductless business for a long time. Central stuff came a little newer to us, and so we needed to jump into that. So 6 years ago, when I got the call from Midea, to come work for them, we needed to get into the central ducted stuff. And so we created the EVOX brand, and we came out with that in what we call the Generation 2. But then, as we know, we stepped it up big time in the innovation, because we're an innovation company. And with the EVOX G Cube and the modular air handler and some of the auto voltage detection we'll talk about specifically in Cody's application, and the modular design in Cody's application helped us a lot as well. When we have to put those things up into attics on second floors, boy, just the ease of doing that, safety. These are contractors, so workman's comp comes into play as well if they get injured. And so we just try to make it as easy as possible for contractors and our distributor partners.
And that was one of the things that I noticed. Most people know Midea from the ductless solutions, but as you go into central ducted systems, split ducted systems, that's a whole different animal. And so you from what I've seen, you reached out to contractors, you reached out to educators, looked for, what are the solutions that you're wanting to introduce into that. And
that most important part of what we did, honestly, was get that feedback from contractors and from educators on what the industry was missing. And they helped us pave the path to the current product. And why not ask the folks who lay their hands on this stuff every day?
Exactly. And that's why it's important that we bring a contractor into the conversation. So Cody, you were an HVAC contractor, built a business, sold the business, decided you were going to do retrofitting in your own home. So let's talk about this project from the get-go. Like, what was the deciding factors? We had some fun conversations the other day about, going this direction. And it's a big choice to dump a gas furnace, no matter where you live in the country.
Well, I had met David at the ACA National Conference, and I was actually at that time in escrow for this house. And so I'd gotten the home inspection report. I knew it was going to be a mess, even if it was new. I'm the kind of guy that I want it to be my own design and, something really nice. I've had quite a few different systems. So I knew I was going to get rid of it. So it wasn't like some difficult conversation for me. And I've had so much experience with heat pumps in the past. And David brought up like such a great opportunity with Midea and the product that they have, that it was a no-brainer for me.
All right. So you started with one of the struggles that every contractor around the country starts with, is systems that are not properly sized to begin with. So where did you start on this project on load sizing?
Yeah. So this house had 2 4-ton AC systems, and it had 200,000 BTU gas furnaces for heating this place. So I can't remember the exact totals. It was like 5x heating capacity. And we ended up, after the heat load calculation, put in 2 3-ton heat pump systems. That's it. We just finished like our biggest heat wave of the summer last week. No problem. System performs amazing. It's extremely comfortable.
So like in your scenario, you're designing for cooling load, and the heating load isn't as important. In other areas like here in the Midwest, I've been focusing on designing the equipment based around heat load calculations, because with our inverter, we have, such a decent range of operation in the cooling. We have, proper turn down ratios. There's a lot that we can do. But for you, it really comes down to having enough heat, but primarily focusing on the cooling and the operation of it there. All right, so some other things that go into consideration, ESCO has been working very close with different energy providers and training networks. We work real close with the California Tech Clean organization and the training opportunities that they're doing. You also work with HVACR?
Yeah, just got on the board a couple months ago.
Right. And so in California, what kind of conversations are you hearing about like grid demand and grid resilience?
That's not my area of expertise, my friend. That's
No,
not the area that I've really gotten tied into. Plus, like my recent going from just a member to being on the board with IHACI is more focused on like the benefits that they're providing and the changes they're making to grow the organization, help the industry with training, and help the industry with workforce development.
Yep.
So I have been focused on grid.
Well, so that's something that I follow pretty close. We work with a lot of organizations in the area, and California as a state is doing a significant push for heat pumps. And part of that is understanding the load, calculating it properly, selecting the right equipment, but in particularly looking at systems that have the capability of managing when they're running, right? Looking at those optimal times for operation. And so we're going to start hearing things like that across the country more often, understanding the cost of energy, whether it is in a natural gas fuel or in electric, and the different energy rates per day. I was talking to somebody here in Illinois 3 weeks ago where they actually already have 3 different costs per day for energy. What is it like in California for electrical costs?
Yeah, we're on a tiered system. And so I think our peak tier is about 47 to 53 cents per kilowatt hour. And that's, peak from 4 to 9 p.m. And there's other times throughout the day that are less expensive, of course. They want you to charge your car, from midnight to 6 a.m. and, run your AC or turn off your AC during peak time, which is the peak time that everybody needs to run it, of course. That's the whole reason.
Exactly. And that's the beauty of using these types of inverters. When we look at what those costs are per day, we can start focusing on capacity control, right? If we look at here in the Midwest, we had a program 15 years ago. One of the local energy co-ops was looking at managing grid use during peak demands. And so they started focusing on air conditioning because that was one of the higher electrical demands. Their solution was to shut off 100% in the middle of the day on peak load. Doesn't actually function. But when we have systems that can actually look at that and we can program to operate at different capacities in different price ranges, it opens up a whole lot of flexibility for how we can utilize our electricity. So looking at energy from the gas and from the electric perspective, let's talk about the installation and the conversion process that you went through.
Okay. Yeah, this started out back when ultra low NOx was coming out here in Southern California. 4 different counties is where they tested ultra low NOx on us. And I was looking at the product and not excited to use it. It wasn't very good. And, manufacturers were saying all sorts of things, but a lot of my friends were having problems with them. And we skipped past ultra low NOx gas heating and just went straight to heat pump and kind of pioneered that. And so I wanted to test this in my own home. And I put in a dual fuel at that time, variable speed heat pump outdoor and modulating 96% gas furnace indoor. And I ran the heating that entire winter with just gas. And then the next winter, I switched it to run only heat pump heating and compared the 2 costs to each other. And it was actually less expensive to run heat pump that following year than it was gas the prior year. And keep in mind, like utility rates have gone up every single year. Right. So that had one little thing going against it. But I knew from then, like heat pump was the way. We weren't struggling to keep up with demand. The only complaint that we would get was from somebody who was used to just taking the chill off in the morning. They let their house get into the 50s and then they go turn on the heater and it heats up really quick. That's not how a heat pump works. So we taught them, put it on a system, put it on a schedule like it's supposed to. And, people are just now comfortable. And so the big change was like, instead of people not liking their heater because it's too hot and it's so uncomfortable and maybe it smells bad, and only running it to take the chill off in the morning, now people run their heat much more because it's comfortable kind of like what I talked about in the video is like, this is a comfort system, not a, I want to save utilities system. Like you don't put it in just to save utilities. It's for comfort. And so this added heat pump versus gas added a massive improvement in comfort on the heating side as like the biggest impact. And then when I was able to verify myself in my own house over a couple of years that it's even more efficient, I mean, it's just, that was amazing for us that I could preach that to my sales team and to my customers, and that they would know that we're not just making stuff up.
Yeah, I actually have a local contractor here in central Indiana that has changed their model over the last 7 or 8 years. Initially, they were a gas furnace for every installation. And then they started switching over to a hybrid model. And now they only offer heat pumps for every installation. That's the only thing they'll do. They prefer the inverter heat pump because they can customize it. They can tune it to do whatever you would like. If you want a lot of heat and you want that thing to perform and respond quickly, absolutely. It's not going to be as energy efficient, but it will provide what you're looking for. So there's a lot of custom tunability within an inverter. Now, installation wise, so you're actually in the attic for your gas furnaces in California, correct?
Correct.
All right. So David, when we look at the EVOX generation, let's talk about the modular solution that was created for this.
Yeah, when, like Cody said, when we met at the ACA convention last year, we started talking about his house, and he had just bought the house. He was waiting to close on it. Well, if I could have thought of a case study, this was it. I mean, because so big house, multiple levels, and then second level, and then his gas furnaces were horizontal in the attic space. And to his point, way oversized on both heating and cooling. So, the more is better scenario in HVAC, we've got to get over that, right? Absolutely. And so when we tore out the old gas furnaces, and he did a complete duct job as well, he did it right, did a complete duct job of ACA Manual J. We knew exactly what the sizing needed to be. But when we got the old coils and the gas furnaces out, with the new Midea GQ breaking that down into 3 pieces, now all of a sudden, instead of that one big 150-pound air handler, you got to hoof up some steps or up a ladder. Now we bust that thing down into 3 pieces, and it's so much faster and so much safer to do it that way. Click it together, lay it down, hook it up, and we talk about that auto voltage detection. Cody not needing auxiliary heaters, that 115 that was going into his gas furnace, it's plug and play with this product. So you plug it in, it automatically recognizes the 115, runs off of it, and says, I'm good to go.
All right. So I noticed that at AHR this year. So it's an auto detect for voltage.
So it can run off of 115 or 208, 230. And whatever you hook up to it, it automatically recognizes that and says, I'm good to go. So let's face it, if you have an auxiliary heater, you're going to have to run on 208, 230. We can't, maybe we'll get to the point one day we can run an aux heater off of 115, but I think we're a pretty good ways away from that. Yeah. So in Cody's environment, and plus the performance of the heat pump, the heat it puts out, there's no way he needed an auxiliary heater. So what we saved him on this install was any additional electrical updates or expenses, because that 115 automatically says, hey, I sense 115, I'm going to run off of it. No switches, no dials, nothing. And it runs off of that 115 on the air handler up into the attic. So we did no electrical updates at all on this house other than changing the disconnect outside. That was it.
Okay. All right. So, one of the things that you'd pointed out when we were talking about, the systems itself, there's a little bit of a learning curve, both from the manufacturer getting the products into the contractor's hands and the contractor talking to the homeowner about the differences, because you're right, it's not your grandpa's heat pump.
Education is key. I mean, this, even the heat pump that I have in my house is the first heat pump I've ever had, because I was a naysayer as well, because I'm an old guy and bald, I'm cold all the time. And so I'm like, no way that heat pump will ever put out the heat that I need in Louisville, Kentucky, because we still get some cold winters here. But boy, was I wrong a few years back when I joined Midea and I put it in, totally wrong. And so I actually prefer my heat pump heat over any gas heat because it's way more consistent. And being modular, right, an inverter-driven compressor, it will go up and down with the load of the home as it goes out throughout the day or at night. And it's just a slow modulation up and down. We follow the load line. It just keeps everyone way more comfortable.
Okay. Very, very intriguing. Yeah, I had some good conversations and comments coming in because we're not used to seeing a 115 volt air handler, and the fact that it's auto sensing kind of changes, especially when we're looking at the conversions, because that's really what part of the push that we see across the country is for, and you can call it whatever you want, electrification, degasification. It's really about finding the right solutions.
Yeah, it's about flexibility.
It is
what it's about. And for me, and my idea from a manufacturing and product development standpoint is we just want to give you as many options as we can give you. And then you and your contractor decide what one of those options is best for your home. That's exactly what Cody and I talked about. What option is best for your home? And that's what we put in, and it works perfectly. So whether that's straight cooling gas furnace, whether that's straight electrification on the heat pump, or whether it's a dual fuel option, let's find out what's best for you and do that. But boy, let's run a manual J load calculation first to make sure it's sized appropriately.
And I just realized I failed you guys and the show. I didn't get those extended heating data tables uploaded. I will do that right now. So I think what we'll do, I'm going to let the two of you talk about the results of this. I'm going to go grab that data, get it uploaded as separate photos. That way we can actually chat about heating performance and cooling performance.
Yeah, that's okay. So, I mean, Cody and I could talk about this for days, and we've got 30 minutes left. But again, when we talked at ACA in Las Vegas, we knew, and then Cody had heard me blabbing about Midea for so long. So, and the timing was just impeccable with what he had going on, moving into the new house, what he had in the new house. We knew he had the perfect product for it. We just needed to get the timing right. And so somehow through magic, we got all the timing right, got a production crew out to San Clemente, got the new system installed, and it speaks for itself, but I'll certainly let Cody speak about the results that he's seen so far.
Yeah, that was there was actually a lot to juggle in the timing with so many different hands being in the pot. But it worked out. You're right, through magic and the grace of God, timing all just lined up perfectly. But these systems are like, when I have small group in my backyard, I have people make sure that they enter my backyard from the street through that side yard. Like, I want them to walk by these AC units. Kind of like, if my wife had the kitchen remodeled, she'd probably want to make sure everybody got to see the kitchen. I'm the nerd that's like, come look at my air conditioners. And but everybody is just blown away by how quiet it is. They look awesome. They almost look like they're part of Star Wars or something. But they're amazing performers. I've had really high-end variable speed product in my last house and the house prior, and like, this system keeps up with everybody else, anything else I've ever had. So the comfort for me is like, one, I never hear the system running. Two, I can almost never feel it running. Like, unless I walk really close to a vent and I feel some cool air flowing out, like, that's the only time. Like, if I'm in bed, if I'm on the couch, if I'm in the office, like, I'm not feeling air blowing on me. The home is just perfect how it needs to be. And we just leave it at 71 degrees 24/7. And it's really nice. And now, again, 2 systems, and my electric bill has gone from no operation. Like, I didn't run anything. I never ran the old system because it's disgusting and gross, and somebody else's, you guys saw the video, like how terrible it was. So we just had no air conditioning and the windows open for a couple of weeks or a month, and then put these 2 systems in. My bill didn't even go up $100, and I keep it at 71. So extremely efficient, extremely affordable, really excited for the years to come with it.
Excellent. I'm going to go ahead and hop over. If we want to share, we'll share that video real quick. We'll kind of walk through the actual system, and then I'll have the extended heating data tables pulled up and we can take a peek at things.
Some home upgrades change the way a space looks. This one changes the way it feels. At this San Clemente coastal home, an aging HVAC system is being replaced with a comfort solution designed for everyday living.
Here in Southern California, there's days where you want to run the heater in the morning and then the AC during the day. It's year-round needs for heating and air conditioning to stay comfortable. I'm Cody Novini. I've been in the HVAC industry about 15, 16 years, and now been consulting and helping other companies. Sat on the board for the ACCA. With older systems, they get less efficient. It's overheating, which causes it to draw more energy. The AC actually cools the home less. When you don't maintain your system, the corrosion ends up causing a refrigerant leak. This home is drastically oversized in heating capacity, and you'd think, oh, it's doing great, but it's not comfortable.
When Cody and I talked through it, he actually needed way less than what the old system was doing. So 2 3-ton Midea EVOX G cubes was perfect.
Heating and air conditioning is for comfort. It's a comfort system versus an efficiency tool. With the Midea system, what's awesome, especially for the installers, is that it's much smaller and more compact.
It's really nice that the Midea actually comes apart in different sections. We're able to get each section up individually, even in tight spaces.
When the guys are lifting that into the attic, it's safer and it's faster. That air handler actually has auto voltage detection.
Whatever the house is providing, we're able to hook up and it automatically knows what voltage it's using. So it's really ease of use for our production crew. Screwless latch design. It's screwless self-sealing for the homeowner. They don't have to worry about hearing the drills constantly throughout the day.
I think with a company like Midea, it's got such a large footprint in the whole world. They have a lot of research over all the different type of climates. There's a strong stability behind them. It's more ironclad that I can trust that the brand's gonna last a long time.
We gave you a lot more room on your walkway here. This is putting out probably 55 decibels, which is basically the sound of a quiet conversation.
And I love the look. It's so sleek. There's nothing else that looks like this. It's extremely quiet. It's not blasting out a ton of air all the time. With variable speeds and inverter systems, it just flows the warm air or the cool air to keep comfort right where you want it to be.
We've got outdoor unit, indoor unit, wall control, and they constantly communicate. It's going to do what it needs to do to keep it at the comfort level that you want. So that's a good thing.
It's great. I really like the dehumidification option. It's got all the features that I want in a thermostat. Good heating and air system, you don't even notice it. It just does everything automatically on its own. For me as a homeowner, I want a system I can trust that it's gonna last, it's gonna perform well, it's gonna keep the home nice and comfortable.
Hi. Now, David, before I jump over to our cooling and heating data tables, one of the things that I noticed in the video was the eye check, and I want to talk about that just a little bit if we can before we head over there.
Yeah, I mean, it's one of the commissioning tools that we have now. We're actually working on enhancing that commissioning tool as well to go a little bit deeper, but that was post-install. We had just clicked the system was running. We actually went inside right after this scene and shot the scene from the wall control. So I check basically when you hit it, and homeowners can do this. It's almost, we call it almost like a doctor's visit for your HVAC system, where you walk in and you hit the eye check and you hit it, and it runs a quick check of make sure everything's running the way it's supposed to. And you either get green check marks or you'll get a little X, and that gives you the opportunity to be a little retroactive or ahead of the curve on calling your contractor and go, boy, this thing said it's not working appropriately. Is there something I should do? Maybe you should come out and take a look at it before the system fails, which is super important.
Yeah, absolutely. Especially on the commissioning side. So we're going to be talking about system commissioning a lot going forward. We're actually working with some public utilities as well as Federal Energy Agency, I guess I could say that much, on what the connected commissioning of a system looks like going forward, verifying that when a system is installed, that it is the right size, it is performing properly, it's not oversized and never going to reap the benefits that the proper system could. So the communication is going to be quite a bit going forward. All right, I'm going to go ahead and share screen here real quick. We'll get rid of the presentation. I'll leave it over to the side for a little while. All right, so we're going to start with the heating side. We'll start with the cooling. That's the first one, because this is the one that was really the most important for Cody. Now, how hot does it get in your area?
Oh, it's terribly hot. It's like, I think 78 degrees over here. So we're just near death. No, I'm kidding. We can get to maybe 95 at the beach, and our hottest slightly inland is like 118. That's not common, but like in the high 90s and a couple days in the low 100s.
Okay, so let's pick on the 95. Like, we're already right here. It's one of our test parameters. So this is one of the things that I encourage contractors to dive deep into when they're looking at products. I've said it many a times, not all heat pumps are created equal. Right? There's so much variation in capabilities, and it's important to know what a product actually does, not just something at 47 degrees, not just something at, a number unrealistic. I want to know what this thing does in my area, both for heating and for cooling. And that's where these extended heating data tables come into play. And we've been doing a lot of training on utilizing the extended heating data tables, the curriculum we put together that California Tech Clean is using, our high-performance heat pump curriculum. We spend half of a chapter diving into data tables to understand what the actual capability. So let's look at that 95-degree range. And this particular one, my airflow, 1,235 CFM, pretty realistic for these 3-ton units that you would be operating. At a 95-degree, now this is outdoor dry bulb, right? And we look at design on this particular one, indoor wet bulb, 67 degrees, indoor dry bulb, 80, all right? So that's a pretty realistic day. If you've had setback, if you've had a bunch of kids running in and out, it's pretty realistic to fire a system up on a day and have a pretty good load on it. So now we're talking a little over 3,000, which is what's really cool with our modern inverters, is that, with a true inverter, we can go above 100% rated. As long it's not hard to do as long as our system is staying in parameters. But that's where, having the thermistors and transducers and the algorithms that are tuned properly for running, we can manage a variety of different applications. This thing it starts trimming down itself as it gets hotter out. But we're even running all the way up to design parameter of 122 degrees Fahrenheit. That's something pretty new, David, when we start looking at air conditioning capabilities. Cold climate, sure, that's a direction to go. Hot climate is something we're seeing a lot more of. I had one day, we did a show here a couple months back. We were in the middle of corn sweat here in Indiana, which most people don't even know corn sweat. It's when all the cornfields release their moisture all at once. I had a 130-degree heat index one day. 96 degrees with 70-some% relative humidity. Miserable, right?
Yes.
As we start looking at systems, we have to make sure that we have our cooling capacity on our hottest of days. And this is something fairly new in the industry.
So, and that is why the technology has come so far. We've changed what we call our systems to all climate heat pumps. I talked about GMC compressors earlier. So an advanced compressor, if you're doing it for cold climates, you're also going to get some major benefits on the cooling side too. It is an advanced compressor. And so we've dialed that thing in to where you're going to get some incredible cooling capacities during very hot weather and some incredible heating capacities at very cold climates, all in one package. And so instead of different SKUs for our distributor partners, you can stock one of these things and you've got, the UP of Michigan taken care of, and then you've got South Florida taken care of as well.
Mm-hmm. And that's where it's been a bit of a challenge for contractors in adopting products because they may be looking at one solution and might not be fitting their application. And they go, oh, well, these heat pumps must not work in my area very well because the product I was looking at didn't fit the bill. And that's where we have to really dive into these. So when I look at that, we have 122 rated. For those that like to shut their homes up and actually run cooling at 47 degrees Fahrenheit, we have those applications. And we're still at 47 degrees, a 41,000 BTU unit. So a wide range in the cooling. We look on the heating side. This is where I get excited because I live in a cold area. I live in an area where I get down into the minus teens. Not a lot, but I do some in the winter. So if we look at, let's say, an outdoor, let's start at 47. I like to start at 64 myself, just because I can see that this thing will tune itself back down when needs be. It doesn't have to run 100% if it doesn't need to. It can actually modulate wherever it needs to go, down into very low turn down ratio if need be. So at design, 47 degrees, outdoor dry bulb, and we're going to pick on 70 degrees Fahrenheit for our indoor dry, right? We're not looking at a 3-ton. And this is where it's very important for people to understand. If I have the airflow capability, I have the ductwork capability, this particular one running at still 1235, right? I have the ability to exceed what traditionally people would say is a 3-ton heat pump, right? And that's where our mindset has to change. Our mindset has to get away from tonnage. We have to look at what is the BTU capability of this thing in heating mode and cooling mode at different parameters. Because what you'll find systems that will be in that tonnage range. And then if you look over at their heating at 47, you go, oh, it's in that tonnage range. Is that a good thing or not? Here in the Midwest, I want to know what that total capability is. And so that's what I look at is where can I go? And then as the temperatures start dropping here in the Midwest, like I'm a 3-ton unit at minus 13 degrees Fahrenheit. I'm cranking. Yeah. Oh, yeah. And so this is one of the things that we see with a well-designed, well-tuned inverter is that because we're running 3-phase motors, we can run a variety of capacity. What one speed could be considered 100%, that might not be anything. We might decide that's just a speed. Let's go beyond this speed. And it's in managing the compressors properly where we get these capabilities. So this thing's actually rated down to minus 22 degrees. I still have 27,000 BTUs. So Cody's never going to need this part that gets me so excited, but he really needs this part, which is also very exciting.
Yeah. So again, Clifton, one product that can do both of those. And I remember looking at this chart. We were 100% cooling at 110 Fahrenheit, if I remember correctly. So you've got a product that can do 100% heating at negative 13, 100% heating at 110. I think we've gotten most of the U.S. covered with that one product.
Yeah, exactly. And it's not easy to do. And as you start looking in equipment matchups, we typically see products that are designed to work in one direction or the other direction. But when we're talking a wide span, that's a whole different story. And that's a lot of engineering and technology, which is why I wanted to have some of this case study for us to talk about, to be able to really show what we're seeing out of these.
Yeah, and we did another quick example. So a colleague of mine, when he first started, we try to get these systems in colleagues' houses so they can feel it and see it and hear it and all of that. So he had a heat pump in his house, and when we took it out, immediately some of the thought process was, well, we need to go back with what we took out. And to your point, Clifton, very important. You better look at the performance ratings, the extended performance ratings, because a heat pump is not a heat pump is not a heat pump. And so what we find out is when we look at that, we actually had the ability to downsize him by a full ton and actually outperformed the old system by downsizing by 12,000 BTUs and keeping them more comfortable, and which, as you know, stops that short cycling. And that's where the discomfort comes in. And we short cycle on, and that's heating and cooling both ways. So we went from a single stage to a true all season heat pump, and we had both covered, and he's way more comfortable than he's ever been.
I got one more. Let me get back over to our slides real quick. We got one more that we need to cover as we're getting closer to the top of the hour. And I'm going to let you handle this for a second. I'm going to step out just for a minute. I will be right back.
Yeah, so if you want to know more, and again, I can't thank Clifton enough, if you want to know more about the product that you see here, MideaComfort.us is the perfect place to go. If you're interested in buying the product or want to know more about it, the info HVAC.na@midea.com will get you hooked up. So, and then I'll turn it over to Cody.
Yeah, I've been just working on building automated systems to help me save all the headaches that I had to deal with when I was a contractor. So lead nurturing, customer re-engagement, handling the whole customer intake when CSRs are either not doing their job or not available. And also my friends that are complaining about AI voice being so terrible right now. So we've been creating some AI text solutions and these other platforms called Pocket Technician. Pocket-technician.com is the website for it. But it's pretty young and it's pretty awesome. It's been a lot of fun. I get to hang out with all my old friends again and help them out with their businesses. So and get to hang out with you guys, do stuff like this.
And it is a lot of fun. And I hope you've all enjoyed the conversation. I know it's a little bit more on the product side than we have on the technical side, but there was a reason for that. I wanted us to be able to look at a study of what we would traditionally, or what some of the industry would call, a cold climate heat pump being used in an opposing application, where it can be used in a hot climate heat pump as well. And so I hope you've all gotten a lot out of this. We had talked about, what's happening in the industry with heat pumps. I encourage all of you to spend a little time in the high performance heat pump, where we'll help you understand these extended heating data tables, what they mean, how the applications are only as good as the load calculation and the product selection. And of course, a good contractor doing the installation. But there really is a big change in the designs of heat pumps, and that's going to continue, right? We're now talking about systems that operate down to minus 30 degrees Fahrenheit, that could operate above 122 degrees Fahrenheit in cooling. These are things we didn't talk about just a few years ago. So it's important that we all stay up to date with these transitions. All right. One of the things that came in was for, diagnostics. In the communication side, do we see the ability to view any of the things like thermistors and transducers within the system?
Now we're working on that. So that's going to be an advanced software that we've got. And we think specifically as we interview contractors and we ask them, would you like to be able to see how the system's working remotely? And the answer is yes.
Yes.
I don't want to spy on Mr. or Mrs. Jones, and I'm not interested in what their set point is. I just want to make sure that this system that they spent a lot of money on is running the way it's supposed to run. And this will take out the emergency service calls. Yes. And so we're working on some advanced software items now where you'll be able to do that soon.
And I've been saying this for a little while. That is the evolution of this industry. I hope that all the educators that are joining us are preparing your classrooms, for this wave of transition. I know it's a lot. That's why we try to bring all of our manufacturers, and today even a contractor homeowner, in to have the discussions on this transition, because it's a lot to take in. It's a lot to look at the system, but it's what we should have been doing all along. And so it's nothing out of the ordinary. We're sizing, selecting, and installing properly. And then now we're starting to look at the actual service and commissioning of it. It's things that we've done in the commercial and industrial side for quite some time and is now really moving into the residential. So I encourage all of you to spend some time, learn more about the entire Midea product lineup, because you're not just doing cool things with this. There's a lot of exciting products out there. And for anyone that missed last week's update, we do have a new EPA 608 that is going to be coming to the industry. You're going to see transitions in the next few weeks with content. Make sure that you log into the Proctor portal if you're an ESCO Proctor. Make sure that all of your contact information is up to date so that we can keep you informed as the new curriculums come out. And December 31st, technically January 1st, will be the last day that we'll be able to use the current EPA 608 certification training and tests that are out there. So the next few months are going to be a transition period for everyone. We just make sure that you are up to date with everything, and we need your current information to be able to do that. So guys, I sure appreciate you joining us today. I love talking heat pumps, and I love seeing what they can do even in other than cold climates. And I hope that everyone's enjoyed the conversation, and we will see you all again next week on Did You Know, the ESCO HVAC show. Bye, everybody.
Thank you, Clifton.